Hi everyone, it's Mrs. Summer here to talk about Lesson 301, Functions versus Relations. In this lesson, students will be able to identify whether a set of data is a function or a relation, and describe the domain and range of a function. What is a function? A function is a relationship with one or more variables where each input has exactly one output. So if we look at our little function machine, when we put something in, we can always expect a consistent result to come back out. So we put in something for x, we apply some type of mathematical operation, and out of the function machine comes y. And here, our inputs are independent variables. And our outputs are dependent variables. Our outputs are dependent upon what we put into it. So a function, each input has exactly one output. So an example of a function would be ordered pairs. So -8, 1, -6, 3, 2, 2, 0, 5, 5, 0. There's one x has one y output. But not a function. If you look here, we have -9. Our x values, we have -9, -1, -1, 3, and 0. But if you look on our y's, we have 1, 5, 2. And if you look -1, 5, and -1, 2. So that means that for each x value, there's more than one y value output. Okay. Same for this table. Over here, this table is a function because for each x, there's one specific y. And then for over here, we have x, we have a 3 and a 3, but this x, 4 and 6. So for 3 and 3, for our x values, you can output a 4 and output a 6, which is not a function. Here we have two different y values, but they correspond to a different x, which means it's still a function. You can have two different y's, but they have to have a different x. And graph, this is a function right here, but this is not a function. Mapping, if we look at the map, this is a function, but over here, because this 5 corresponds to 4 and 3, it's not a function. So if we look at this at a little different perspective, identifying a function from a table, table 1 is a function. We have 4, 2, 7, 2, 8, 5, 12, 10. So even though over here we have the same y's, each x, this goes to 2 and this is 2. So the y's can be the same, the x's, you can't have two of the same x's going to two different y values. Over here, so table 2 has repeating x values with different y values, which means it's not a function. An easy way to identify a function from a graph is the vertical line test. If any vertical line only passes through its graph once, it's a function. So here, this circle, if we were to draw a vertical line, it passed through here and here, which means it's not a function. But anywhere on this other graph, we draw a vertical line, and it only passes once through your graph, it is a function. So you try. Is this a function? Is this mapping a function? And is this graph a function? Remember to pause this and rewind if you need to go back and look at the videos again. For question number 1, an easy way to figure it out is just list our x values. -3, 1, 3, 5. And then we're going to look at our y values. We have 7, 5, 4, -8, -11. So we don't have any repeating x values. which means yes, it is a function. For the mapping, we have 2, it goes to this 2 to 2 different y values, which means no, it is not a function. And if it's not a function, it's a relation. And then over on question 3, we can do our vertical line test. And as you can see, our vertical line passes through 2 different points on the graph, which means not a function. It is relation. Domain and range. The domain are all of the x values. They're the input. They're what we put into our function to get an output. So they are all of our x values. So if we're looking at this example here, we need to figure out our x values. So we can just start by writing our coordinate points. We have 1, 2. Then for this one, we have 3, 3. Then we have 4, 2. We also have, 5, 4. In this point, we have 2, 6. So if we're going to list all of our x values, so 1, 3, 4, 5, 2. So we're just going to list those x values as 1 in numerical order, 2, 3, 4, 5. So our domain is 1, 2, 3, 4, and 5. And over here, it's a little bit different. Our domain, because up here we keep going, and if we extend our line, it's going to go towards negative infinity. And all the way over here, it'll go towards positive infinity. So our domain for this graph is negative infinity to positive infinity. So you try. What is the domain for the following graph? So here I've already listed out the different coordinate points that we're seeing. So we see, oops, that is a pen. That is not a highlighter. So we've got -3, -1, 1, and 3. So we can write our domain as -3, -1, 1, and 3. Our range is all of the y values, so our outputs. So at all of our y values, so we're going to do the exact same thing that we did for the domain, but do it for the range instead, for the y values. So now we're looking at our y values. So we've got our 2, 6, 3, 2, and 4. So our range is going to be 2, 3, 4, and 6 is our range. Okay, we don't have to double up because there were 2 2s. We don't have to write the 2 twice because it's already included in the first 2 that we write. And on this graph over here, we now are going in our vertical direction. So if we look, this graph goes from positive infinity all the way down to 1, and then it jets back up and goes back towards positive infinity. So we can write this as 1 to infinity as our range, because 1 is the lower part of our range. It doesn't go any further than 1 on our graph, but it does go up towards infinity in both directions. So you try, what is the range of the following graph? So if we look at our list of coordinate points and we're looking at the y values now, These are my y values, and I can write them as 0, 2, and 3. Those are the ranges of my y values. And remember, because they doubled up, we don't have to rewrite them.